right, we have a brief review time today, and want to go over the terms that you will need for the exam. So here's probably the best way to do it. I'm just going to kind of call out definitions to you or ask for definitions. Don't try to write the definitions down, but if there's a term that you do not know, write the term down. You can always go back and look up the definition later. So, what is physics? The study of the interaction of two things. Matter and energy. We've talked about matter at the beginning in the first 5 chapters. We talked about energy here lately. And so the study of how those two things interact. Interaction of matter and energy. One of the reasons we study science in general, physics specifically, we can figure out how things work. We can make things work to our advantage. We talked about banked roads, for instance, earlier, right? Well, studying banked roads helps us to make sure that cars can go faster through turns, so we bank the roads properly. Have a better overall driving experience, fewer accidents, fewer people on motorcycles flying over. Anyway, pendulum clocks, right? And studying the laws of the pendulum and things like that, right? All these things are ways in which we can better ourselves. So having dominion over the earth that God has given us is one reason we study physics and science. Another reason is because God reveals himself to us. I think as we've seen just in this first semester, we've seen how everything is so orderly and mathematical, right? And that reveals a intelligent designer. For everything to run according, if things happened by accident, there would be no math to discuss, right? There would be observations of, hey, we seem to see this, but there wouldn't be math to discuss if it weren't for an intelligent designer, correct? So by seeing math and everything, we know there is a God who carefully designed this planet, carefully designed the way in which things work. Physics reveals the mind of God, if you will. We call this God's revealing of himself through his creation. I mean, it is divine, but that's not what we call it. General revelation. General revelation. God revealing himself through nature. Now, to know who Jesus is, right? The Christ child, born of a virgin in Bethlehem, gave his life for us on Calvary so that we could be redeemed back to God, our Creator. That we make the Bible for. Because nature doesn't tell us that. We need God's special revelation for that. Let's see. We went over SI units in our last review time. Scientific notation we've been using constantly. Dimensional analysis we've used a lot. Sig figs we use a lot. The exactness of a particular measurement that we might take. Remember we had the timer there and we were taking some readings, right? And so the exactness of a particular reading is called... Accuracy is the exactness of a reading. And then if we got the same reading, you remember looking at the pendulum, for instance, passed back and forth through the timer, and the numbers fluctuated just a little bit. But we noticed that the first 2 digits, maybe, of the period, it didn't change. We're like, okay, ignore the last digits because they keep changing anyway. We can't rely on those. But those first 2 seem to be consistent. Consistency within a series of measurements we refer to as precision. Good. When we get error in a measurement, if the error is due to unpredictable happenstance, randomly the knot in the string from our pendulum suddenly it was a nice loop and suddenly the loop just goes down to nothingness, and so the length changes in the middle of a reading. Okay, you can't account for that. I mean, maybe tie a better knot, but I mean, you really largely can't account for it. We would call that random error. However, error that could be avoided. For instance, every time we swing the pendulum, it keeps hitting the timer. Okay, change the release point or move the timer so it doesn't get hit, right? And that's causing errors in reading. Or maybe if with our springs, right? We drop the springs down into the timer. Well, if we brought it down and it didn't actually go into the photo gate fully, and so it didn't actually trip the timer, well, then pull it down a little bit more, right? Or slide the timer up a little bit more. Add another physics book under the timer, right? Error that you can avoid. Error maybe for using a faulty instrument, which I didn't use any of those examples, or a faulty method, which is what I was kind of alluding to, we call systematic error. Anything that has mass and takes up space, we call matter. Of course, physics, the study of the interaction of matter and energy. All matter has this unique property that it resists a change in its current velocity. What do we call that? Inertia, resistance to change in velocity or change in its present state of motion. What is the amount of force that Earth's gravity exerts on an object's mass? Weight. Weight, very good. What is the ratio of an object's mass to its volume? Ratio of an object's mass to its volume. Density, very good. We said the most basic building block of all matter is called? The atom. Chemical combination of two or more atoms? Well, if they're the same atom, yes, it would be still an element. A molecule. A molecule. Now, a substance in which all atoms are exactly the same, that is an element. If all molecules are the same. Compound. 4 states of matter. 2 of them have no definite shape. We refer to them as fluids. And what are those? Gas and liquid. What's the difference, though? The gas doesn't even have a definite volume, right? Where a liquid does. Plasma. Where do we believe plasma to be? Obviously, we can create plasma, but where do we believe plasma to naturally exist? Specifically in the stars, right? We believe that those are plasma, which would make it then the most abundant state of matter in our universe. But on planet Earth, the most abundant state of matter is? Liquid. The other one, liquid, right? Because liquid goes down deeper than gas goes up. In the nucleus of an atom are 2 types of subatomic particles. Protons and neutrons. And then buzzing around the nucleus we have, of course, protons are positive, electrons are negative, and neutrons are neutral. If you were to change the number of electrons that an atom has, it would give it a charge. Ion. If you change the number of electrons, you get an ion. And we said if you take electrons away, that's going to result in a... If you take electrons away from an atom, you strip electrons. Cation, because it'll be positively charged. If you were to somehow add electrons to an atom, if it were to take electrons from something else, adding additional electrons, that would give it a negative charge. It would become an anion. So Andre keeps trying to say isotope. Isotope has nothing to do with the electrons. What's the isotope deal with? He's like, it's either protons or neutrons. And he remembers, wait, if you change the protons, you're changing what it is. It's got to be neutrons. And isotopes are substances with usually additional neutrons that have been added, changing the mass of the atom, or the mass number. Let's see, what is that relativity equation that relates energy and mass together, thanks to Albert Einstein? E equals mc squared. The implication is that near the speed of light, at a great energy level, mass seems to be created. So light can sometimes be thought of as having little particles of light. These little packets of energy, bundles of energy, are called photons. Protons and neutrons, they believe, are made up of littler things held together called quarks. With liquids, we said that a liquid tends to maintain the smallest surface area possible. We call this resistance to increased surface area? Surface tension. It's caused by a couple of intermolecular forces. One of the forces is the water molecules stick together. We call this cohesion. But the water molecules will also stick to whatever attempts to penetrate them. Adhesion. Adhesion, cohesion also help to explain, along with atmospheric pressure, the rise of liquid in a narrow tube. Capillarity. We said any push or pull on an object is called force. Force per unit area is called pressure. The primary factor that affects liquid pressure. Depth is the primary factor affecting liquid pressure, unless the liquid is confined. In a confined liquid, pressure is everywhere the same throughout the liquid. So pressure that's applied, transmitted equally in all directions, we call that Pascal's principle. Pascal's principle helps to explain the operation of a device that uses a confined liquid to multiply force? Hydraulic device uses a confined liquid to multiply force. Another guy noted that when an object is submerged into a liquid, the liquid pushes back up against that object. What do we call that upward force acting on a submerged body? Buoyant force or buoyancy, I would take that. And Archimedes found that buoyant force was equal to the weight of liquid that is displaced. So however much liquid the object displaces, that weight of liquid is equal to the buoyant force upward. Talked about liquids moving and flowing, and we said that in general liquids have some degree of resistance to flow because of adhesion and cohesion and things of that nature. What do we call this resistance to flow? Like trying to pour syrup out of a bottle. But if you heat the syrup, it decreases this. Viscosity, good, the viscosity or viscousness. It's viscosity, but whatever. If you were to have liquid flowing through a pipe or through a tube of some kind, and the tube were to narrow or pipe were to narrow, what would happen to the liquid? Faster. It would move faster to get through. What do we call the bombardment of air molecules on a surface? Surface pressure. Or air pressure. Air pressure. If there was no air or any other matter, then we would have a vacuum, which could result in death, right? But a vacuum. By the way, I was thinking about this the other day. I had a candle at one point in my classroom for Christmas that I like to burn. It smelled really good. And I burned it so often, of course, you know, the wax disappears and there's just barely any left. So I finally threw the candle out. And I threw the candle out because it always says on the bottom of a candle, I don't know if you've ever looked at this, once the wax gets to within, I think it's a ½ inch or an inch or whatever, throw the candle away. Don't continue burning it. Well, Mr. McDonald had a nice, candle in his classroom back when he was teaching years ago. And he was burning the candle. And of course, the wax was going lower and lower and lower. He just kept burning the candle. Well, as you know, the candle is burning up oxygen, right? And the warmth is causing warm air to rise out of the candle. And so as the warm air was pushed out of the candle, there was no gas or air left in the candle. But there was plenty of air on the outside. It was one of these larger candles with a cool little facey looking shape to it. And the atmospheric pressure actually crushed the glass jar the candle was in, caused it to shatter. And it was very strange in the middle of this class. Bam! And there goes the candle. And there was not enough wax left in the bottom to continue pushing back outward against the walls of the container. So anyway, that's why it says that, because that's what can happen. And you're creating it, in a sense, kind of like a vacuum inside the candle. Anyway, thought about that just today, so I thought I'd throw that in there. If the speed of a fluid, we'll think gases specifically, the speed of a fluid increases, the lateral pressure decreases. So remember we took the couple pieces of paper and blew down between them, and the lateral pressure in between decreased enough that the air on the outsides pushed the papers together. Whose principle was that? Where you blow over the top of a piece of paper, the piece of paper rises. Bernoulli's principle. Good, Bernoulli's principle. What do we call an instrument used to measure atmospheric pressure? Barometer. Who's credited with inventing the barometer? Evangelista Torricelli. What is standard atmospheric pressure? An atmosphere? 760 torr. They left you with the hard one. Anyway, thanks guys. I want to write this one down. 1.013 E5 pascals. 1.013 E5 pascals. One scientist guy noted that if you increase the pressure on a gas, what will happen? Hold the temperature the same, but increase pressure on the gas. Volume will decrease. If you're increasing pressure, you're going to decrease that volume. And as you decrease the volume, the internal pressure must increase as well. Another guy found that if you heat a gas, the gas will expand, so that volume and temperature are directly related. Dr. Charles's law, volume and temperature directly related. What do we call a device that transports air or is driven by air pressure? Any device. Well, that would be an example of one. Pneumatic device, P-N-E-U, P as in pneumatic. All right, pneumatic device. By the way, we do have pneumatic brakes and hydraulic brakes on cars, right? So most cars use hydraulic brakes. There's brake fluid you have to add. Semis, though, and buses and stuff use air brakes. That's why you have to have a special license to drive those because they handle differently. Let's see, we talked about the ability of a solid to maintain its shape. We said solids have a definite shape. That ability to maintain shape in general is called elasticity. Elasticity. Two components. One is the ability to resist deformation. I pound on this and nothing changes. If I did that with Play-Doh, I would leave knuckle marks. The other one. Rigidity. Other things, though, I can deform and then they would bounce back, like the rubber ball we talked about, right? As the rubber ball is thrown on the floor, it compresses down, but then it pops back into its original shape, and that's why a rubber ball bounces so nicely. That ability to recover original shape, or a rubber band, stretch it out, shoot it, pick it up, hey, it's the same shape it used to be. We call that resilience, the ability to bounce back after deformation. Deformative force per unit cross-sectional area we call deformative force per unit cross-sectional area. It's kind of like pressure, but it's deformative pressure, if you will. Stress. That's what you're feeling right about now with exams. Relative deformation is called strain, and stress and strain will be proportional in most instances. We said any quantity that has both direction and magnitude, vector, and a quantity that has magnitude but not direction, scalar, good. Speed in a particular direction, velocity. Straight line distance between 2 points, displacement. What negative sign is used to indicate? Opposite direction, I'll take that. Change in velocity per unit time. Change in velocity per unit time. For instance, most cars can go 0 to 60. Some cars can do it in very little time. Some cars, like really old Saturns, might take a lot longer to get, I don't know, might take longer to get from 0 to 60. Or a bus might take a lot longer to get from 0 to 60. Acceleration, right, is the change in velocity per unit time. Of course, slowing down, we would refer to that as deceleration. For an object in free fall, if there were no air resistance, what would be approximately the acceleration rate for an object in free fall? There, you're going to have 0 meters per second squared. But because of air resistance, the object doesn't really accelerate at that rate continually. All objects at some point reach a velocity, if they don't hit the ground first, would reach a velocity at which point they would no longer continue to accelerate, but would fall at a constant rate. Obviously, a parachute employs this principle. We call this fastest possible velocity due to air resistance terminal velocity. What do we call a single vector that shows the outcome of multiple concurrent vectors? A single vector that shows the outcome of multiple concurrent vectors. It does start with an R. Resultant, the resultant vector, good. Anything that's launched or hurled through space without the ability to continue propelling itself. Projectile. The path of a projectile is referred to as its trajectory. And if it weren't for air resistance, what would be the path, the shape of all trajectories? Parabolas, or at least a portion of a parabola. So parabolic trajectory might have been a better way to word that for my part. Newton's second law of motion was what little equation? F equals ma. Newton's first law was called the law of inertia, which says that velocity doesn't change unless there's an outside force present. Well, acceleration is a change in velocity, so to have acceleration there has to be a force, F equals ma. The third law of motion says that for every action there's an equal and opposite reaction. For instance, as I stand here, there's weight pulling me down. Well, I'm not going down. Why not? Because there's an equal and opposite reaction upward called normal force. The floor exerts a normal force on me, which is good, because otherwise that'd be really strange. Trapdoor suddenly takes away the ability of a particular portion of a floor to exert normal force. Yeah. Anyway, If an object slides across a surface, it creates a resistive force arises. We call that resistive force. Friction, the force that must be overcome to start sliding the object. Static friction. Once the object's in motion, there's a lower value of friction needed called kinetic friction. What does friction depend on? Two things. Weight. Sort of. Normal force. Friction depends on normal force and the coefficient, which basically is what kind of surfaces are rubbing up against each other. What's the strongest of all the fundamental forces in the universe? Believes to hold the nucleus of an atom together. Strong force. What's the weakest force? Good, not weak force, gravitational force, which is always an attractive force between two bodies. What is a force that exists between charged objects? Electromagnetic force, good. Johann Kepler came up with laws of planetary motion. His first law says that planets, when they go around the sun, go around in what shape? Ellipses, go around in elliptical orbits. As a planet gets further from the sun, what will happen to the planet? It will slow down. As a planet gets closer to the sun, it will speed up. Any force that's transmitted through a string, rope, cord, or other connector is called tension force. Tension force. What do we call a single force that is equal to, in magnitude, but opposite in direction to the resultant? A force that is equal in magnitude to the resultant, but opposite in direction. The equilibrant. The equilibrant. Lots of free body diagrams and stuff. There will be one problem from chapter 9 dealing with ramps. We've done a lot with ramps. There will be a ramp problem on the exam. There will be one on your homework handout tonight as well. Motion that repeats itself after the same lapse of time. Periodic motion. Motion in a circular path at a constant speed. Circular path, constant speed. Uniform circular motion. Uniform circular motion. For an object in uniform circular motion, although the speed is constant, there is acceleration. The acceleration is always towards the center. And that center-seeking acceleration is called centripetal acceleration. And centripetal acceleration must be caused by some force. Specifically a centripetal force, right? Centripetal force causes centripetal acceleration. We talked about tension being a centripetal force. We talked about friction being a centripetal force. We talked about weight in the X on the banked roadway being a centripetal force. All kinds of stuff like that there. We said, talked about an object hanging on a spring, going up and down, up and down, up and down with periodic motion. We said that the force that pulls the spring back upward, or if it's like a coiled spring in a pen that you squish in, that force that pushes back outward toward the balanced state is called restorative force. Good. The amount of stretch in a spring is called when you stretch out the spring, and that's how high and low, without neglecting frictional forces, that the mass will rise and fall. Displacement from that equilibrium, balanced position. Amplitude. I should say after the spring has already reached equilibrium, the amount that is stretched from equilibrium is called amplitude. Sorry, poorly worded. Motion that repeats itself after the same lapse of time and along the same path. Oscillatory motion. Motion repeats itself after the same lapse of time and along the same path and is caused by a restorative force. Simple harmonic motion. Number of oscillations per unit time. Frequency. Time required for one oscillation. Period. We already said frequencies measured in hertz. We reviewed that the other day when we were reviewing SI units. What's the main thing that affects the period of a pendulum? I mean, time is the period is time, but the main thing that affects the period of a pendulum. The length of the connector, good. Transfer of energy from one body to another is evidenced by motion. Work is that transfer of energy. Time rate of doing work. An object designed to make work easier. Machine. Simple machine that is basically a ramp we would refer to technically as being inclined plane. An inclined plane wrapped around a rod. A screw. What do we call the distance between the ridges of the screw? The pitch. What do we call a long and flexible object designed to pivot? A lever. What do we call the point at which a lever pivots? The object the lever is intended to move? The load. Gave you the law of levers equation in the last lesson. What do we call the ability of a machine to multiply force, thereby making work easier? Mechanical advantage. Remember, we had two types. If you actually take the ratio of the force you get out to the force you put in, that's called actual mechanical advantage. If you look at the ratio of the distance you put in to the distance you get out, ideal mechanical advantage. What do we call the ratio of output work to input work expressed as a percent? Efficiency, or the ratio of AMA to IMA, right? Because you'll never get out more actual mechanical advantage than you put in. At best, you get 100% efficiency. Talked about three classes of levers. Which class of levers has the output or the load in the middle, like a wheelbarrow? Class 2. Which one has the fulcrum in the middle? That's class 1. Remember, by the fulcrum being in the middle, you can kind of change which lever arm is longer. You can either multiply force or speed. Class 2 only multiplies force. Class 3, what's in the middle? The input force, and that only allows you then to multiply speed. What do we call two inclined planes back to back designed to cut or split? A wedge. What increases the ability of a wedge to multiply force? Good. Increasing the depth of a blade or the thinness of a blade. Let's see. A circular lever used to redirect force. A circular lever used to redirect force. A pulley. Multiple pulleys used in combination. Block and tackle. Two wheels either affixed to the same axle or connected in some way. Wheel and axle. There we go. Two wheels of differing size, specifically. That allows you to multiply whatnot. Ability to do work. Energy of motion. Energy an object acquires when it's exposed to a force. Potential energy. We generally think of potential energy as being gravitational potential energy. There's also elastic potential energy. What's the main factor that affects elastic potential energy? The amount of stretch in that spring or elastic object. Spring, restorative force, stuff like that, and gravitational force. These forces, you can define potential energy very easily. Work really doesn't depend upon the path taken. Because the total kinetic and potential energy tends to remain constant. We refer to forces like gravity, springs, even electromagnetism, though we didn't really talk about that, as being conservative forces. Other forces that would cause energy to be lost, the sum of kinetic and potential to be lost, are called non-conservative forces. What do we call this sum of kinetic and potential energy that is in some way affected by non-conservative forces? Sum of kinetic and potential. Mechanical energy. Mechanical energy. Now, specifically, if the mechanical energy is lost and converted instead into heat, which then evaporates, if you will, into the surroundings, we refer to that force, like friction, also as being a dissipative force. What is the product of an object's mass and velocity? Momentum. What is the change in an object's momentum as a result of a force applied for a specific length of time? The product of Ft. Impulse. In the absence of external forces, we said total momentum is always conserved. And we use this for collisions, right? And so in all collisions, if there are no outside forces, in all collisions, so momentum is conserved, sorry. If kinetic energy is also conserved, we would have something called an elastic. If kinetic energy is also conserved, it's called an elastic collision. If it's not, it's inelastic. If two objects stick together, completely inelastic collision. And that is the terms that you will need for your exam. Now, for homework, we have one last math review. I know we just had some math with that quiz that I gave you, which went over earlier. You'll see some of that math again with a handout for this evening. We'll be going over this in our next lesson, our last lesson, in fact, which is our final review for the exam. So go and do this handout in study hall or this evening as you prepare. Tomorrow we'll go over it on video. And then we'll be ready for your exam to wrap up this first semester of physics. Have a wonderful rest of your day, as you are dismissed.